everyone, welcome to EMQ webinar. I'm so glad to have you all. Today we are going to talk about how to ensure MQTT security with TLS in EMQ X. In this webinar, we will share how to properly configure TLS certificates in EMQ X and how to use OpenSSL commands to understand what is contained in the certificates, and certificate trains and verify that they are correctly installed in EMQ X. After the webinar, please be sure to check out the uploaded video on YouTube. We will provide scripts and instructions in the description so you can try out what you have learned. Today, our speaker is Kary Ware, who is EMQ pre-sales engineer. He has strong hardware and software engineering background and worked with customers in a wide range of industries. Before we kick off the webinar, I would like you all to know that we will be recording this session and all participants will be on mute by default. If you have any questions during this webinar, please type them in the Q&A box or raise your hand. After permission, you could talk with speakers directly, and the questions in the Q&A box will be answered in the Q&A part at the end of the webinar. We will share the recording of the webinar and slides in the follow-up email. So let's move on. Welcome, Kary.
Thank you very much. Hello, everyone. So today I'm going to show you how you can ensure MQTT security with TLS and EMQ X. So here's the agenda. First, I'll give an introduction to EMQ X products, both cloud and on-prem. Then an overview of TLS security and how to verify certificates and certificates chains using OpenSSL. Then how to map certificate files to EMQ X listeners, both cloud and on-prem. Then I'll give an example of how to map Let's Encrypt certificates to EMQ X. And then I'll show a short demo on how to generate self-signed certificates and how to map them to EMQ X. And then we have a separate tutorial video that I'll explain a little bit later, so you can try all this out for yourself. And then finally, summaries and questions and answers. So now a brief introduction to EMQ X Cloud and on-prem products. So with EMQ X Cloud, we have 3 plans: standard, professional, and unlimited. And all plans offer a high performance, fully 100% MQTT compliant message broker. And all plans have a rule engine that allows you to process messages in real time. In the standard edition, you can have up to 10,000 connections. In the professional edition, you can have up to 100,000 connections. Plus, it supports an extended rule engine that allows you to persist data to external databases such as MySQL and MongoDB. You can also forward messages to Kafka. And it's the one I'm going to be using today because it also supports TLS. And if you need more custom configurations or more than 100,000 connections, then contact us and we will let you know about unlimited options that you have in our unlimited plan. And if you want to know more about EMQ X Cloud, see the other video that we did just on EMQ X Cloud. For EMQ X on-prem, we have 2 products. We have the EMQ X Broker or Community Edition and EMQ X Enterprise. And just as before, they both offer high performance, fully 100% MQTT compliant message brokers. They both have a rule engine that allows you to process messages in real time. With the Broker Edition, you can have up to 100,000 connections per node. It does support TLS. With EMQ X Enterprise, it's based on the broker, so you have everything in broker, plus it supports 1 million connections per node. And it also allows you to persist data to many popular databases. And also it has a Kafka bridge. So you can try any of our products. Just go to emqx.com and click the try free button, and then select cloud or on premises, follow the instructions from there. And I just want to point out that you don't need a credit card to try any of our products. So next I'll give you an overview of TLS security. And I'm going to focus on the certificate exchange in the TLS handshake, the certificate exchange between the client and the server. So when we talk about security in MQTT and EMQX, there's really two levels. One is the username, password, and client ID, where the client sends the username, password, and client ID in the MQTT connect packet. And then the EMQX broker validates the username, password, or client ID using an internal or external database, such as MongoDB or MySQL, et cetera. And you can turn this off for testing purposes. And then the other level of security is at the transport layer, or TLS, that includes encryption and authentication using trust certificates. There's one-way TLS, where the client verifies the identity of the server, and two-way TLS, where the server also verifies the identity of the client. So TLS security and certificates are going to be the focus of this webinar. So an example of one-way TLS is where the client verifies the identity of the server. So the client sends a hello message to the server using the server's host address, and then the server sends back a certificate or certificate chain. And then the client verifies the certificate against a trusted root CA, a root certificate that it has. So when it verifies a certificate, it's expecting to see a subject containing the server host address that it used to contact the host, and then an issuer that's issued by a trusted CA that it has. In this case, there's multiple certificates that are issued by intermediate CAs. So they need to have a valid link between the issuer and subject for all of the different certificates so that they form a valid trusted link. So in this case, the issuer and the subject match in all cases. So it's a valid certificate chain. But if there's any break in anywhere, so if this issuer and this subject didn't match, for example, then it would not be a valid certificate chain and the client wouldn't connect. And just to point out, the certificate chain is including, but up to, but not including the root CA, because the root CA is contained in the client's list of trusted certificates. So just to point out that the certificate chain does not include the root CA. So for two-way TLS, where the server also verifies the identity of the client, so if two-way TLS is enabled, and if the one-way TLS has successfully completed, then the server requests a certificate from the client. And the client, and then in this time, the client sends back a certificate or certificate chain. And it's the server that verifies the certificate against its root CA, root CAs that it has. So basically, it's the same thing. The server is looking for the client's domain in the subject and looking for an issuer that's issued by a trusted root CA. And if there's any intermediate CAs, then they have to have valid trust links between the issuer and the subject, where the issuer and subject match. So again, this is a valid certificate chain because the issuer and subjects match. So when you set up clients and servers for TLS, you need to provide the client software and the server software with the following information. So the client has to have the root certificate for the server, and it also has to have its private key. And then the server needs to have a valid certificate chain from its host address to a trusted root CA. And in addition, it has its its private key also. And that's for one-way TLS. For two-way TLS, in addition, the client also has to have a valid certificate from its client domain up to a trusted root CA. A trusted root CA that the server has. So the server has to have the trusted root for the client. And for EMQ Xon-prem, all of the trusted CAs are contained in a file called CA certs. So you provide this information to the clients and servers through public key certificate files and private key files. So here's some examples. Maybe you use Let's Encrypt. So if you use Let's Encrypt, here's the files that you will get, the certificate and private key files. If you use the self-generated certificates that we'll be using in the demo and the tutorial. These are the files you'll see. And then also EMQ Xon-prem has some self-signed certificates that you can use, and they're in the etc. certs directory. So I'll talk about those later. But so the next step is, okay, you have all your certificates, but how can you examine them and understand what the files contain so that you know how to map them to the broker? So now I'll talk about how you can examine the files before they're mapped to EMQX using OpenSSL commands. So in part 2, I'll show you how to test their certificates on a running broker. But for right now, we're just looking at the files that we have. And just a note is that the OpenSSL version should be at least 1.1.1, and that's to be compatible with TLS 1.3. So the first thing you may want to do is just print out the files. So if we print out server.pem, for example, we'll see a bunch of encrypted information, which isn't so useful. But all the files do have a plain text tag at the beginning that specifies whether it's a certificate or a private key. So that's useful. So at least you know whether you have a key or a certificate. Another thing you can do is you can grep that information to see how many certificates are in a file, because remember, a file could contain multiple certificates. So another thing you may want to do is you may want to verify that the certificate and key pair match. So if you use the OpenSSL p-key command on a private key, it will extract the corresponding public key from that file and perform a hash. And then you can compare that hash to another public key in a different file. So for instance, here the server key and the server PIM files, they both hash to the same value. So we know that that's a valid pair. But if we pick a couple of other, like the client key and the server PIM, they don't go together, and therefore their hashes don't match. So in the tutorial and in the demo, we have wrapped these commands inside of a script called verify. So the verify script assumes the server, assumes the files have the same name, just the key and PIM extension are different. But this script allows you to use any key certificate pair. So these scripts you can use if you try out the tutorial later. Another thing that's interesting is to be able to look at the subject issuer chain all the way through for all of the certificates that the file contains. So if you use this command, you can see the localhost, you can see the subject issuer for all of the certificates that are in the file. So it allows you to more easily trace from the subject domain all the way up to the trusted root certificate. And so in the tutorial, we've wrapped those commands inside of a script called trace. So you can try that out. So if you want to see what the trusted root certificates that are in EMQX, you can apply that command to the CA certs file that's in this directory, and it will return all of the trusted CAs that are contained in that file. So you can see which trusted CAs EMQX has. And if you do a grep on that for trusted CAs that you're interested in, so maybe the root CA for Let's Encrypt, which is ISRG, you can see that, yeah, the EMQX contains the root certificate for Let's Encrypt. So if you want to see all of the contents of the certificate, you can use the same command as before, except with the addition of the /text option. And that will show you all of the details of the certificate and all of the certificates that are contained in the file. So I want to point out that the OpenSSL X509 command works if you have one certificate in the file, but if you have multiple certificates, it will only show you the first certificate. So this is a much more flexible and more general command to use. So next we'll look at some examples. So one thing that could be interesting is to look at the X509 extensions. So if you just grep for X509, you'll see those. And it's important to know that the subject could actually be in the extension. So that trace command may not be completely accurate if the subject is contained in the X5 or not extension. So if the trace command from before doesn't really make sense, then you need to go to the extensions to try to find a valid certificate chain. Another thing you may want to do is look for the certificate validity. So if you grep for validity, that will show you how long the certificate is good for. So now that you've used SSL to look at the files and understand what the files contain, so the next step is to actually map them to EMQX. So there's 4 ways that clients can connect to the broker. One is through just normal MQTT and port 1883. Another is over WebSockets on port 8083. And again, just to note that these are plain text connections. So there's TLS, corresponding TLS connections for both of those. So there's secure MQTT and secure WebSockets, and they connect on these ports. And these ports are the default ports for EMQX. You can change them if you want, but these are the default ports. So for the EMQX dashboard on the on-prem broker, you can connect using HTTP on port 18083, or you can connect over HTTPS, which uses TLS. So if you want to verify the ports that the brokers are listing on, in EMQ X Cloud, if you go to the overview page, connected ports, you'll see all the ports and the connections that the broker is listing to. For EMQ Xon-prem, if you go to the dashboard settings and listeners, you'll see a list of the ports and the listener types that it's listing to. So the ones that are underlined in red are the TLS listeners. And for TLS to work properly, the EMQX broker needs to have the correct files, certificate files. So here's an example of how to map certificates to EMQX Cloud. If you go to the TLS config, you'll see 3 different parameters that need to be mapped. So the certificate body and the certificate chain, together they need to form a valid chain from the server domain up to, but not including the root CA. So in this example, we have server.pem, which just goes to an intermediate CA, and server.chain, which completes the chain. And the cloud guys can correct me if I'm wrong, but I believe the certificate body can only contain 1 certificate. So if you have a file with multiple certificates, you have to break it up. So to my understanding, that you're only allowed to have 1 certificate in this file, but the rest of the certificates can be mapped to the certificate chain. And then the certificate private key is the server's private key. And in this example is server.key. So for two-way TLS, then you need to provide the client's root CA to the server, but that's only for two-way TLS. So for mapping certificates to EMQ Xon-prem, there's a couple of parameter definitions that are used throughout the configuration. And one is the key file. So it always points to the server's private key. So in this example, server.key. And the cert file parameter always points to the certificate chain, not including the root CA. So in this example, it's the server.full-chain. Another parameter is the CA cert file for two-way TLS. And that contains the root CAs for all the clients. That is, if they're not already included in the CA certs.pem file that EMQX already has. So this is just more of a breakdown. For Enterprise Edition, the parameters are located for SSL and secure WebSockets. Those parameters are located in a file called listeners.config. And the HTTPS configurations are located in a file called EMQX dashboard in the plugins folder. But they all have the same sort of look and feel for their mappings. They all have key file for the private key. It's the same in all of them. cert file is the full chain, and the CA cert file parameter is the roots CAs for the clients. And just a note, if you're using Community Edition, then that file is called EMQX.config instead of listeners.config. So if you want to use the EMQX self-generated files, certificates, they're located in the EMQX certs directory. And so basically you map the key.pem file to the key file parameter, that's the private key, and the cert.pem to the cert file parameter. And notice that the self-generated certificates don't have an intermediate CA, so it's just one certificate. And for two-way TLS, then the CA cert.pem maps to the CA cert file. And then of course you have to supply the clients with their corresponding certificates and private keys. So you could, if you wanted, you can use the self-generated certificates for EMQ X Cloud. All you have to do is map the cert.pem to the certificate body. Basically, that completes the chain because there's no intermediate CAs. So then you would need to map the key.pem to the certificate private key. And that's all for one-way TLS. And for two-way TLS, then you map the CA cert.pem to the client CA parameter. So to switch between one-way TLS or to configure the broker for using one-way TLS versus two-way TLS on the EMQ Xon-prem, it's through a parameter called verify. And if that parameter is set to verify none, then it's one-way TLS. If it's set to verify peer, then it's two-way TLS. And on the cloud, it's just a drop-down box, either one-way or two-way TLS. And then for two-way TLS, there's an extra parameter where you can decide what you want the broker to do if the client doesn't supply a certificate at all, whether you want that to fail or not. So now I'll give you an example on how to map Let's Encrypt certificates. So if you get Let's Encrypt certificates, by default, they're going to be located at etc. Let's Encrypt live in whatever domain you choose. And these are the files that you will get. The root file is not included, but you can download it manually if you want. But the root certificate for Let's Encrypt is contained in the cacerts.pem file. So if you look at examine the files, you'll notice that it's the full chain.pem file that contains the full chain. The other files are just partial chains. So it's basically the full chain file is the one you want to use. So to map the Let's Encrypt files to EMQ Xon-prem, then the privkey.pem maps to the key file, and the full chain.pem maps to the cert file. So basically, that's it for one-way TLS. And to map the Let's Encrypt files to EMQ X Cloud, the cert.pem maps to the certificate body. And then basically, you can choose either the chain.pem or the full chain.pem to complete the chain. And it's actually okay if they overlap. So if you use full chain.pem, it will actually overlap with the cert.pem. So you can use either one of those files. Then the privkey.pem maps to the certificate private key. And then for two-way TLS, you will have to generate the certificates some other way. So this won't be from the Let's Encrypt certificates that you have. These will be generated for the client. So now that we've mapped the certificates to the brokers, we can use OpenSSL to verify that the certificates are correct on the running broker. Again, just as a reminder, OpenSSL should be at least 1.1.1 or above. So OpenSSL has a command called sclient that connects to the running broker as a client using TLS. So it's good for troubleshooting, verifying that the certificates are right, that you didn't misspell anything in the configuration, or that everything is correct. So basically, they connect to the host name and a port, and you can use any one of the TLS ports that you want. So one useful thing may be to grep for the certificate chain, just so you can see that the valid chain actually running on the broker. Just a note for S client is it writes both to standard out and standard error. So if you just grep, what you'll get is you'll get a grep on standard out, but you'll get all of standard error. So it's maybe not what you want. So it's a good idea probably to use this command, which maps the standard out to the the standard error to the standard out before it's passed the grep. So then grep will behave the way you intend. So if you really want some verbose output, you can turn on these options. And in the tutorial, we've wrapped this command in S-Client SSL, S-Client Secure WebSocket, and S-Client HTTPS. And you'll get a bunch of verbose output that you can analyze to look for errors. So here's some examples. Some common errors are if the certificate chain is broken, you'll see a command that says it's not a valid chain. If the S client cannot verify the host name, then you'll get an error that the host name doesn't match the certificate. Just a note that if you want, you can grep for multiple options. And if there's no certificates at all, it will return error 104. And if you grep for the certificate chain, then it will be blank. So this is a good way of analyzing that the certificates are correctly on the broker the way you think they are. So now I'll talk about the hands-on tutorial that's in a separate video that goes through the process of generating the certificates, verifying they work for both one-way and two-way TLS. So in the tutorial, what you'll do is generate the certificates, look at the certificate files using OpenSSL, map them to the brokers, test them using one-way TLS and MQTT X. Then you'll add the root CA to the browser and test HTTPS, and then configure the brokers for two-way TLS, and then also test the two-way TLS connection. And there's a script called workflow that shows you all the instructions that you need for all the steps. So the setup I have for the demo and what you can use for the tutorial is I have Docker Ubuntu image on Windows with EMQX Enterprise installed in the Docker image. But of course, you can install EMQX directly on Linux. This is just a way to test out using Windows if you want. Then I have MQTT X to test the clients. In EMQ X Cloud, I have the professional plan running on AWS. And just a note that the Docker Ubuntu image that I have with a EMQX install is not the same as the EMQX Docker install that you would get if you go to our download page, because the Docker install runs on Alpine Linux, which is much smaller. So just so that there's no confusion between the setup I have and what you would get if you download Docker from our website. So now I'll give you a demo on how to generate self-signed certificates and map them to the cloud. So let's come over here and look at our brokers. So we have EMQ X Cloud. And if I look at the clients, I can see I have two clients on the broker. These actually are the plain text clients, one for MQTT and WebSockets. So that's EMQ X Cloud. And if I go to the dashboard, I can see I have two corresponding clients here too. So let's go actually look at the clients, and you'll notice that there's actually 4 clients wanting to connect. There's 4 clients wanting to connect to the local broker, and 4 clients wanting to connect to the cloud broker. And basically, these are all the different types. So this is normal MQTT, WebSockets, and then the TLS versions of both of those, both local and the cloud. And just to point out, these are separate brokers. They're not bridged. So, the messages are local to each of these brokers. So The ones in green, those are the plain text clients. Those successfully have connected. But if we try to connect one of our TLS clients, bad things happen and they're not allowed to connect. And the reason they're not allowed to connect is because the certificates are not installed on the broker. So let's go fix that. So right now I'm inside the Docker Linux. I'm in the etc. certs2 directory. So this is your starting point if you want to do the tutorial later. Just some directory. I called it certs2, but you can call it anything you want. And the one thing you want to do is to verify your OpenSSL version. So I'm running 1.1.1. So that's okay. So it's compatible with TLS 1.3. So if I go to the workflow, which is actually inside the same directory, it's just a little bit better for the demo. And I do workflow steps. I can see all the steps I need to do for the tutorial. So if you do the tutorial, this is what you'll see. So the step that I want to do now, or we want to do now, is to generate certificates. So if we specify step 1, this will tell us all of the steps we need to do in order to generate the certificates. So the script that does the actual work of generating the certificates, it reads from the environment variables. So if you do this, the first thing you want to do is actually modify this environment.config file to match the certificate parameters that you want. So the first thing I want to do is do source config. So now I've configured the environment variables for the local broker. So if I generate the certificates, you'll see that I have a new directory here with a timestamp. So I'm going to rename that. So now I've renamed it to local, and let's look at that. So now I have, I've generated the certificate files for the local broker, and let's do the same. So now I've configured the environment for the cloud broker. So let's generate them again. Again, I'm going to rename the directory. So just to recap, what I've done is I've generated 2 sets of certificates, one for the cloud broker, one for the local broker, just to keep things simpler for the actual certificates. These are separate certificates. They cannot be mixed and matched because even though it looks like the root certificate is the same, they're actually different certificates. So we can just look at one. Let's look at if we look at the server.pem file, we see that it really only contains one certificate. And if we do the same thing for the server full chain, we see that it actually contains our full chain from the local host to the root CA. So now we've verified our certificates and we know that it's the server full chain is the one we want. So there's a little bit of housekeeping that I have to do. And that's to copy the certificates down to the host. So if I go to my host machine, you can see I have the same set of certificates here. So now that we've generated our certificates, we've looked at them, we verified them, maybe we verified that the key and the certificates match, we can go install them on the broker. So if I go to EMQ X Cloud, then if I go to the overview page and TLS config, now here is where I can select between one-way and two-way TLS. So I'll just select one-way, certificate body in the cloud directory. That's the server.pem file. The certificate chain is the certificate full chain. And the private key is the server.key file. So everybody's happy. I hit confirm. So Notice it says pending, so it's going to take a couple of minutes to set up. But notice you can see here that it's set up for one-way TLS. And it also shows you the certificate expiration time, so you can see when your certificates are valid, or when they expire rather. And the other thing to note is the connected ports. Currently, until this gets set up, it's only looking for the unencrypted connection. So when this changes to running, we should see these change to include the TLS ports also. So now we've configured the EMQX broker on the cloud, and let's do the same thing for the local broker. So I'm in the EMQX etc. directory, and the file we want is a listeners.config. So I do that, look for key file. Oops. And you notice that I'm in the section for configuring SSL. So here's the key file, and that gets mapped to the server.key in the local directory. And the cert file gets mapped to the server.fullchain, also in the local directory. And if I scroll down a little bit, I don't need to worry, because I'm using one-way, I'm configuring for one-way TLS. I don't need to worry about the CA cert file, so it's commented out. And then I set the verify to verify none. So now I've configured the SSL. So if I do the same search for, now I'm in the secure WebSocket section, basically the same thing. The key file is set to server.key. The cert file is set to server.fullchain. So that completes the whole chain. I don't need to worry about the CA cert file because it's one-way TLS. And then I set the verify to verify none. So no. So that was the listeners.config. So then I can go to plugins directory. And the file I want is EMQX dashboard. So basically it's the same thing. If you scroll down, you'll notice that it's the key file is, it's still key file, and that gets mapped to the server.key. The cert file gets mapped to the server.fullchain. So you'll see the same parameters. Verify is verify none. So basically these are all configured in pretty much the similar manner. So it's important to note that I didn't change anything. All I did was change the certificates. So in the real world, if I did that, I would not have to reset the broker. The broker would automatically update because all I changed was the certificates and not the configuration. But that takes a couple of minutes. So to speed things up, I'm going to restart the broker. But this exact same scenario, you would not need to restart the broker. But just to keep things quick. So now I'm just waiting for it to start. So one more thing I can show you is that the generated certificates are inside the certs directory, so we can look at those. So you can use those if you want to. So these are the ones that are automatically generated by EMQX. So now let's go back and look at our Cloud Console and see if we're done. So sure enough, we're set to running. And if we refresh the screen, we can see now that the EMQ X Cloud is listening to all of the ports, all of the TLS ports, as well as the unencrypted ports. So if we go back to MQTT, because we restarted the broker, these guys have to log back in. So now we can try to connect our secure clients. So one thing to note is that I've already got it configured, but in order to connect in order for MQTT-X to verify the certificate, it has to have the root CA of of the server. So I've already put that in here, so it's already pointing to it. So now it's happy, and I can connect. So all of the clients are now connected to the local broker. Just to show you again, on the cloud broker, so I have to have the cloud root certificate for the server, the cloud server certificate. So I can connect. So everybody's connected. So notice that they're all subscribing to the same test topic everywhere. So if I choose one and publish to the same test topic, you can see now that they've all received the message. So there's no one here because you see the message directly. But as I click on each client, I can verify that they have received the message. So if I choose a cloud client, hit publish, it's the same. So now they've all received the message. So basically now you've seen how to generate self-signed certificates and how to map them correctly to both the local broker and the EMQ X Cloud broker. So that's the end of the demo. And we'll talk a little bit more about our EMQ X community at the end. And then now it's time for questions and answers. Let's see, someone wrote, what if all my certificates are lost? Yeah, that's, it's probably in the broker. Let's see. Yeah, it's probably not good. Then I guess you could regenerate them and point them to the new certificates. And how to revoke the certificates, yeah, I'm not sure. I'll have to ask one of the EMQX guys. Let's see. So there's a question that says, if there's 10,000 two-way clients, then there's 10,000 certificates on the broker. But it's sort of assumed that the clients would be using the same root certificates. So I think as long as you have all of the root certificates covered, I don't know that you have to have 10,000.
Hello.
Yeah, hello.
Yeah, this is timing. I can answer the certificate revoke.
Okay.
Yeah, currently we don't have a certificate revoke mechanism built in. So that's the simple answer. But in the future, we will add the certificate revoke list to support.
Okay. So I don't see any more questions.
I actually have a comment to add.
Okay. Go ahead.
The restarting of the broker to make the certificates take effect was not necessary, as you pointed out already. We actually found out a way to force the refresh. So we'll add it as a command line in the future releases. So you can run the command, and then you can force the broker to reload all the certificates without having to restart the listeners.
Yeah, good, good. And there was another question, how to debug TLS handshake error in EMQX. Shiming, are there any specific EMQX commands that could be run?
No, not inside the EMQX. Unfortunately, not at the moment. OTP allows us to set a debug level for debug level logging for SSL, but that produces a lot of logging load, so that's not recommended to do so. And there's currently no way of configuring such behavior from EMQX. So we don't have an interface for that configuration yet. But to troubleshoot handshakes, doing it from the client side should be sufficient. But usually after the failed handshake, the EMQ X logs some SSL handshake errors. So in general, you should have some idea that TLS handshake failed, but not exactly the details of each step.
And another question is, what TLS library is EMQ X using?
EMQ X relies on the Erlang OTP SSL library, which is actually a dynamically linked integration with OpenSSL 1.1.1.
Okay, there's another question. What about CentOS being EOL? I don't know.
Yeah, we're actually working today to bring in Rocky Linux 8 to replace CentOS 8. So we will, for EMQ X 4.4, we will start releasing on Rocky Linux 8.
Do you know that, Jiming? What about AL 2022?
I can't see the questions, sorry. So I have to rely on you to repeat them.
Okay, it says, what about AL 2022? Fedora on AWS.
We just started looking into it. I'm not sure if it's Red Hat Enterprise Linux 8 compatible. If it is, then you can use the build package from Rocky Linux 8. But actually, we'll rename the packages from CentOS to RHEL. So just not to confuse users. So everything that is Red Hat Linux Enterprise Linux distribution compatible can use those packages.
And another question, can this be used for communication between iOS app and IoT device in local network?
Not sure. Well, if they are using TLS, then I guess so.
It said an additional comment, both iOS device and IoT devices would be on LAN. So I guess as long as they can communicate with each other, that's, I mean.
Yeah, so if they subscribe to the broker SSL listener, then they will need to have their own either root certificate to verify this, the broker's certificate, or provide their own certificates for the broker to verify them.
So that's, yeah, that's all the questions I see.
There is another question in the chat box. Is RHEL equal to Fedora?
Well, Fedora is the upstream of Red Hat Enterprise Linux, right? So I'm not sure if it's Fedora is advancing faster than RHEL, so it might not be compatible for some of the packages. But we will look into actually releasing Fedora packages also if it turns out not to be compatible. You're welcome to submit GitHub issues if you have trouble using RHEL packages in Fedora.
Thank you, Kary, and thanks for your attending again. And if you have any other questions, feel free to contact us in our Slack channel, our Discord server, or GitHub forum. So we will share the slides, recording of the webinar, and 1+ detailed hands-on video in the follow-up email. And thanks for your interest. Bye-bye.